Imagine launching a satellite in space without a rocket. No flames, no fuel, just a giant spinning machine hurling payloads into orbit like a slingshot. That is SpinLaunch, a company promising to revolutionize spaceflight with a kinetic launch system. But how does it work? Let's get into it. What's up guys, I'm Yaza. Welcome back to the channel. In today's video, we'll be diving into SpinLaunch, a company that uses a big giant centrifugal vacuum to transfer payloads into space by spinning the rocket at incredible speed. So SpinLaunch is trying to impart a velocity on payloads, an insane velocity on the ground, eliminating as much fuel as possible from rocket waste while reducing the complexity and size of non-reusable components. The plan here is to spin a small rocket in this giant circular machine with a tube at its end, tangential to its end, called a centrifugal mass accelerator under a vacuum in insanely high velocities before releasing it and enabling it to reach hypersonic speeds, gaining over 70 kilometers of altitude off of no fuel, just pure kinetic energy, eventually splitting up into a two-stage rocket system flying into orbit. SpinLaunch aims to release the aeroshell, the spinning aeroshell, at Mach 6. That's 2 kilometers per second, 2,000 meters per second. And in order for it to reach this speed, the tether with a radius of 45 meters has to spin 450 times per minute, therefore making the tether experience over 10,000 Gs. So this means the aeroshell will exert a force 10,000 times greater than its weight due to gravity. That is why the tether is made of a brick made of different layers of carbon fiber, making it enable to experience incredible amount of forces. But all things said, carbon fiber cannot experience Mach 6 in air. The aerodynamics will cause it to get heated and destroyed. That is why a vacuum is created with no air inside, so that this tether will be able to spin freely. The goal here is to minimize drag, the power required to overcome it, and the aerodynamic effect to make it start heating up. So in order to be able to conduct multiple launches, SpinLaunch required a two-door system that will airlock immediately the aeroshell escapes out of it. So the aeroshell, when it starts spinning and attains the required speed for it to escape, as the first door closes, the second one starts to open. After this happens, the vacuum or the whole machine will be able to do at least 5 to 10 launches in a day. But after launch, the tether will face an imbalance. So there is another weight placed at the other end to counteract this. It's called a counterweight, obviously. So this counterweight was made to hit the body of the vacuum, but eventually cleaning up that mess will cause a lot of problems. So they made it such that it will also get released after the aeroshell has also been released. These counterweights are made of fiberglass. But taking a look at the aeroshell has a bimetallic tip. The cone on the head of the aeroshell is made of copper and aluminum, but copper and aluminum have a high thermal conductivity. When you have an aeroshell reaching speeds as high as Mach 6, it moves through the atmosphere really quickly. As a result, heat is generated and spread throughout the whole body without it reaching the two-stage rocket system or affecting the two-stage rocket system. So after the aeroshell has been launched, it's then split into two, returning back to the Earth's surface. Since the parts of this aeroshell aren't as complicated, after digging them up several feet from the ground, they can be reused because a parachute is used to land them more safer. So you just have like 3 or 4 components with minor maintenances needed. When the aeroshell reaches space, the rocket will be free of the mass of the carbon fiber shell and the bimetallic cone. The rocket just needs a fraction of fuel to accelerate a 200 kilogram satellite through the atmosphere at that altitude. Okay, let's talk about it from the physics point of view. The centrifugal mass accelerator. It uses the principle of centripetal force. You might think it's centrifugal because it's called a centrifugal mass accelerator, but that is not the reason. So centripetal force is the real force acting towards the center of a circular path, keeping the object, like SpinLaunch's payload, in circular motion. The tether in this case pulls inward on the 200 kilogram payload at 2 kilometers per second and over a radius of 45 meters. That inward force is mass times the velocity squared divided by the radius. SpinLaunch calls it a centrifugal launch system because from a practical or an observer's perspective, like a slingshot or a spinning ball tied to a rope and letting go, it's an outward motion. That outward motion mimics what centrifugal force feels like. So it's like an intuitive shorthand. At the release point, the tether stops pulling inward and the payload's tangential velocity built up from all that spinning takes over. It flies off in a straight line tangential to the circle, not because of an outward centrifugal push, but because it no longer has a force that is constraining it. So, is it centrifugal? Technically, yes, but practically, sort of. The big question is, can they handle the cost? SpinLaunch is like a common company with big competitors like SpaceX or Rocket Lab, and they have little investors. They don't have much investors, so they have to look at the cost. SpinLaunch has been able to build a 1/3 scale of this centrifugal mass accelerator at a low cost, but the hardest part of this technology is scale. They have been able to attain 1.6 Mach, and they have tested their ruggedized satellites at 10,000 Gs. So, is this genius or a gimmick? Trust me, the engineering is legit, and the cost and eco-friendly goes a long way if it is actually successful, because these launches are going like several hours per day, not weeks. So they've got NASA's eye looking at them, and yeah, they have a bright future if it actually keeps succeeding. That is SpinLaunch. If you like this video, hit that like button and don't forget to subscribe if you are new to the channel for more engineering and tech breakdowns. I'm Yaza. Thank you for watching again, guys, and I'll see you in the next one.